We're just about to begin the actual implementation of the SDBR approach in our little plant. So let's just recap on our preparations from the previous video. You'll remember we discussed the fact that inventory in the plant obeys a bathtub shaped curve. Too little time and you have chaos. Too much time and you also have chaos. The vast majority of conventionally managed manufacturing plants are on the right hand side of the curve, and they are chaotic as a result. As the first step in our SDBR implementation, we plan to choke the release of raw material to the plant. This will move our conventionally managed high inventory plant from the right side of the curve to the relative calm of the plateau. And it will still leave plenty of time for work orders to make their way through the plant and be shipped on time. Why will this happen? Remember, in a conventionally run plant, the touch time is often less than 10% of the elapsed time. The vast majority of the time the work orders spend in the plant, they are waiting in queues. By choking the release, we allow the work centres a breathing space in which they can continue to work on work orders queued in front of their work centre without any new work orders entering the plant. This lowers the amount of inventory in the plant by at least half, and as inventory equals lead time, we reduce the manufacturing lead time too. To choke the release of raw materials, we distinguish between the quoted and production lead times. We accept orders but hold back or choke the release of raw materials until the start of the production lead time. Remember, due date minus the production lead time equals the raw material release date, and we are very strict in ensuring that work orders are not released to the plant before their raw material release date or released too late, not too early, not too late. Once in the plant, all work orders have a buffer color determined by how far they are into their buffer. Another way to describe this is to say the color of the work order is determined by which third of the production lead time the order is in, or if it's past its due date and it's late, it's in the black zone. Each work center has its own buffer management priority list for the work orders waiting to be processed, and the list is prioritized according to the buffer penetration. Workers choose work orders for processing based on the priority list sequence solely according to the color. Late or black orders have the highest priority, then the red work orders, then yellow, then green. So we're ready to go. We've developed our process to accept customer orders and hold back work orders from production until their raw material release date. Every work order in the plant has been given a buffer color, and we have developed a process to ensure that all future orders will have the appropriate color when they are released, and this color will change accordingly as the work orders move through their production lead time. Let's now follow the SDBR implementation as the different actions take effect over the first few days and weeks. On day one of the implementation, three things happen. Firstly, sales continue to accept customer orders and commit to due dates based on the quoted lead time. So, for convenience, let's assume that the implementation begins on the first day of the month and this month has 31 days in it. A customer places an order, sales accept the order and commits to deliver according to the plant's quoted lead time of 30 days. As today is the first, the due date committed is today's date plus the quoted lead time, which of course equals the 31st of this month. All typical orders accepted today will be treated the same way. Accept the order, quote the lead time, commit to the 31st as the due date. That's the first thing. The second thing that happens is that the accepted orders are not released to production. Instead, they are added to the raw material release schedule for a date determined by the formula, which by now we have all memorized, of due date minus production lead time. So for orders accepted today with a standard quoted lead time, the raw material release date is 31 minus the 15-day production lead time, which equals a release date of the 16th of the month. Nothing else happens. The accepted work orders simply wait. Purchasing may need to examine the work orders to ensure that they have sufficient supplies of the required raw material, but this should be done during the choke period and completed prior to releasing the work order to production. The third thing that happens today is that the work centres in the plant continue to process work orders that are in the queues in front of their work centres, except that today the work centres prioritise which work they do according to the buffer management priority system: black or late orders first, then red, then yellow, then green. The work centre operators are empowered to choose from within a colour zone in the buffer. There may be good reasons from the local perspective to follow a slightly different sequence of production, For example, some work orders may share the same setup as the previous work order or when grouped together. But the key point is the priority system is rigorously followed. Late, red, yellow, then green, and in that order only. And that's it for day one. But the really interesting point is that the combination of the choke and the work centers continuing to process open work orders creates an interesting and wholly desirable effect in the plant. The queue in front of the work center immediately after raw material release, work center 2 in our little plant, begins to get smaller. This, of course, makes perfect sense. The work center continues to work through the day and no new work orders are released to the work center, so the reduction in the queue is inevitable. This is good news. The queuing in the plant and therefore the manufacturing lead time are already reducing on day one right in front of our very eyes. Okay, let's skip ahead now to day 3 of the implementation. Sales has continued to accept customer orders and not release those orders to production. Instead, they have been added to the raw material release schedule for release at a later date. So, what else is happening in the plant? Well, firstly, we can see that Work Center 1 is now idle. It has consumed all of the work orders from its queue, and as no new work orders have been released yet, it now has nothing to do. Let's slow down at this point and think carefully about how we react. Firstly, it is important to note that this is a temporary phenomena. When we begin to release raw material for orders taken during the initial choke period, Work Center 1 will once again have work to do, although we certainly do not expect or want the queues to reach the levels that they were previously at. Also, let's remember the efficiency syndrome. If you are feeling a little nervous or uncomfortable at the thought of people and machines standing idle, it's probably a hangover from before you learnt just how damaging to plant performance every person and machine working all of the time can actually be. In which case, we should remember 2 things. Firstly, the goal of our plant is to make money now and in the future. We are not a public work scheme and we don't exist to give people work for the sake of it. We are here to make money. The second thing we should remember is that our ability to achieve that goal is determined by the constraint. Local optima does not equal the global optima. In the case of our little plant, the market demand is the constraint, so Work Center 1 producing more than necessary to satisfy market demand is highly likely to be damaging to us achieving that goal. In fact, it takes us away from our goal. In almost every plant where SDBR is used, the market demand will be the constraint. Remember, this is the first simplifying assumption that SDBR makes. So what are we really losing by having a few people not producing for a temporary period? The answer is nothing. Nevertheless, this phase of the implementation can cause some concern, particularly to those employees who work at the affected work centres. In one implementation I led, the first work centre after raw material release ran out of work on the first day of the implementation and the initial choke period was for 20 days. This meant they had a lot of spare time on their hands. How quickly the queue is reduced depends on how big the queue is at the start of the initial choke period and the rate of production at the work centre. I talk more about how to successfully handle this phase of the implementation in part 2 of On Time in Half the Time, and I set out some specific steps you can take in order to ensure things go smoothly. Go study that program after you finish part 1 to learn more. So what else is happening by day 3 of the implementation in our little plant? The second thing we notice is that the queue is reducing in front of Work Center 2. This is the same process that occurred at Work Center 1, so I won't labour the point except to say that the faster the queues go down, the quicker we are reducing the manufacturing lead time through the plant. This is emphatically good news. The more subtle thing to notice is that the queues are being reordered to reflect the buffer management priorities as work orders move through the plant. What does this mean? Well, let's take an example. On day 1, Work Center 7, following the buffer management priorities, chooses to work first on a black order. This is obviously good, but what happens to the work order when Work Center 7 has finished with it? According to the routine in our plant, the order must move to Work Center 8, but where does it go in the queue? The buffer management process is very clear. Black orders take priority over reds, yellows and greens. So the work order joins the other black work orders at the front of Work Center 8's queue. The red work orders all shuffle back a pace to allow the new black order a place towards the front of the queue. When you think about it, this makes perfect sense. The work order is already late and we probably have an upset customer wondering when it will be delivered. Having that work order join the back of the queue at Work Center 8 means it would have to wait for all of the black and red work orders to be processed. At least this way, the delay is minimized to waiting just for the other already late orders to be processed. This reordering process is a constant feature in the initial implementation period. The plant is reorientating from prioritizing according to what is best for the local work center to prioritizing what is best for customers. Black orders jump over red, yellow, and green orders when they join a queue. Reds jump over yellow and green orders, but not black orders. Yellow jumps over green, but not red or black orders. Reordering the queues and the work centers then following the correct priorities means that work centers throughout the plant are constantly focusing their capacity on the work orders that are either already late or have the least time remaining before they are due to ship. Another thing that will happen very early on in the SDBR implementation is that if there is a capacity constrained resource in the plant, it will become very obvious very quickly. It's impossible to put an exact time frame on this as it depends on the capacity of the CCR relative to upstream work centers and the amount of inventory in the plant. However, it is very likely that if the plant has a CCR, it will begin to make itself known in the early days, and the way it does this is by having a queue larger than all of the other queues. This is a very simple and reliable way to check the existence of a CCR. You will also notice downstream from the CCR the queues are getting smaller. This is obviously because the downstream resources have more capacity than the CCR and can process more work orders per day than the CCR, hence reducing the queues. In the next video, I will discuss in detail what to do if you have a CCR, but it is really important to note that you should act immediately. Preferably, you would have prepared for this eventuality prior to the initial choke period, but that is not always possible. Not acting immediately will slow the rate at which the plant improves, and from experience, not getting results or taking a long time to get results are two of the most effective ways of killing enthusiasm and support for an improvement initiative I have seen. So, pay attention to the next video, then prepare, and then you will know exactly what to do as soon as the CCR presents itself. Let's now fast forward to day 15 of the SDBR implementation. The plant now looks dramatically different. Upstream of the CCR, the queues have almost entirely disappeared. Downstream of the CCR, there is very little inventory as resources here have ample capacity to process work orders coming from the CCR. The vast majority of inventory still in the plant sits in a queue in front of the CCR. If this was the situation in a real SDBR implementation, and it's not unheard of, all of the focus would now be on improving flow at the CCR. As I mentioned, we will discuss that process in detail in the next video, so for now, let's just assume that people are busy working on that while we observe what happens next in the plant. There is one other thing to note. The buffer management process continues to update the status of work orders through the plant and change the color of the work order as they progress through the 15-day production lead time. All orders in the plant at the start of the implementation will have changed color as they progress through the 15-day production lead time. Some will have changed color as many as 4 times, as they went from green to yellow, yellow to red, and red to black if they weren't shipped on time. This now is a continuous process to keep work centers prioritizing the right things, and typically MRP or production management software can be modified to do this automatically. As you'll no doubt remember, tomorrow is the day the initial choke period ends. Since day 1, we have been accepting customer orders and using the formula today's date plus the quoted lead time equals the due date to give customers a shipping date. We've also been adding accepted orders to the raw material release schedule using the formula due date minus the production lead time equals release date. In our little plant, we've agreed a 30-day quoted lead time and a 15-day production lead time. So orders accepted on the first day of the month will have a due date of the 31st and a raw material release date of the 16th. Orders accepted on the 2nd have a due date of the 1st of next month, assuming this month has 31 days, and a raw material release date of the 17th, and so on, as you can see from the example on the slide. So tomorrow is an exciting day. The initial choke period where nothing has entered the plant is over, and we will release just those work orders that are due into the plant on the 16th. Day 16 begins with the release of raw material for an order accepted 15 days previously on the 1st. The work order is released to Work Center 2, who, because there is no queue at the Work Center, can begin immediately to set up and then process the released work order. Why is this possible? Well, by now I'm sure you know the answer. There is no queue in front of the work center. No queue means no delays waiting for other work orders. So Work Center 2 processes the work order immediately. When I run my SDBR simulation with clients, I make sure everything works in daily buckets of time. This means that the work order cannot be processed by more than one work center in a day. But in reality, this is often possible, and a work order may be processed by two or even more work centers in a plant which has been drained of inventory, like our little plant has. But for now, let's stick to taking it step by step. It's day 16. A work order is released according to the raw material release schedule. There is no queue at Work Center 2, so it can begin to process the work order without delay. Meanwhile, at the CCR continues to process work orders from the queue and to increase flow by taking measures we will discuss in the next video. Resources downstream of the CCR continue to rapidly process work orders coming from the CCR, and slowly but surely the number of black orders in the plant is declining. And if the number of black orders is declining, we are very close to seeing our due date performance rapidly improve. Day 17 sees the release of work orders for customer orders that were accepted on day 2. Remember, due date equals today's date plus the quoted lead time, and the raw material release equals the due date minus the production lead time. And of course, we are only releasing those orders. In the plant, you can now see work orders at both Work Center 2 and Work Center 3 as the work orders from yesterday progress further into the production process. The CCR continues to process work orders from its queue. The plant is focused on improving flow at the CCR, and the number of black orders in the plant continues to decline, and so on. We will continue now to release work according to the raw material release schedule and only the work scheduled for release. This means the queuing remains greatly reduced, and as work orders don't have to wait in queues, the manufacturing lead time is reduced. The non-CCR resources work when they have work, and they don't work when they don't. When they have a choice of what to work on next, they follow the buffer management priorities. Black first, then red, then yellow, then green. It's very simple. The CCR continues to work full time to reduce the queue, and the plant management takes the necessary actions to increase capacity at the CCR and therefore flow through the whole plant. And this is where our attention will turn to next. I will explain how we take a seemingly overloaded resource like our CCR and create a significant amount of additional capacity.